In this lecture here, we want to move into talking about solving quadratic equations by using the square root property. So what I'm going to do is I'm going to introduce the property, talk about it a little bit, and then I have 5 examples of varying difficulty showing you how to work problems. All right, so quadratic equations of the form u squared is equal to d. Okay, so u is an algebraic expression. So it can be something like just x by itself. It can be 2x minus 5 squared, whatever. But u is some algebraic expression, all right? And d is a non-zero real number. Okay, so whenever you have something squared is equal to a real number, you can solve using what's called the square root property. So it goes like this. If u is an algebraic expression and d is a non-zero number, then u squared equals d has exactly 2 solutions. Okay, 2 solutions. So basically what's going on here, and I'll explain it. So if you have u squared is equal to d, what you do is you take the square root to solve. Okay, so to get rid of a square, you square root it. Now, what happens is when you use the square root to solve here, you get 2 solutions. Okay, you get u is equal to the positive the square root of d, or u is equal to negative the square root of d. Okay, so a lot of time equivalently, I'll just write it as, or you'll see it as u squared is equal to d. Then when I solve with the square root, u is equal to plus or minus the square root of d. All right, so what I'm going to do is I'm going to work a very, very simple one here, check it for you and show you that it works. And then I'll work some other problems of varying difficulty showing you how to use this square root property. All right, so let's solve by the square root property here. So here's the first one. X squared is equal to 25. Okay, so notice here, going back, I have something that looks like u squared is equal to d. So what I'm going to do is I'm going to solve. I'm going to take the square root of both sides. Now when this cancels out here, my x is equal to plus or minus the square root of 25. All right, well, what is the square root of 25? It's 5. So what I'm saying here is I have 2 solutions to this equation here. X can be equal to minus 5, or x can be equal to plus 5. And what's really interesting here, and why this works out, why you need both the negative and positive here, if you square both these results, like watch, negative 5 squared, that does equal 25, right? Because a negative times a negative is a positive. And then also 5 squared works out. All right, so whenever you take a square root to solve, just remember you're always going to get 2 solutions here. All right, let's try this one. 2x squared minus 72 is equal to 0. All right, so what you might ask yourself is, well, how do I know I'm going to use the square root property here? It's set equal to 0. This is saying it has to be set equal to a non-zero number. So whenever you have just a squared term and no x, like we've seen in the previous examples where we solved by factoring, you're just going to move everything over to one side except for the squared term. So I'm going to add 72 over. I'm going to then divide by 2. And now look, I have x squared is equal to 36. So I'm going to solve by taking the square root. So x is equal to plus or minus the square root of 36. Well, what's the square root of 36? It's plus or minus 6 here. All right, let's try another one. Let's look at 3x squared plus 27 is equal to 0. All right, so it's just got a squared term. So let's start by moving everything over. Okay, so move the 27 over. Notice how you have minus 27. Don't worry about the negative. I'll show you that in a second. Divide by 3. So 27 divided by 3 gets me minus 9. So I'm going to take the square root now to solve. Well, look here. So x is going to be equal to plus or minus the square root of negative 9. All right, well, we've covered this in complex numbers. All right, so what this means is we have a non-real solution. So the negative is going to come out as the imaginary unit. So it's going to come out as I, and the square root of 9 is 3. So our solution here, our solution to this equation here, x can be either be equal to minus 3i, or it can also be equal to positive 3i. And if you were to plug either one of these in there, you would see that it would work out. You would get a correct solution to this equation if you were to check it out. All right, let's do two others just so you can see some varying, how some other problems might look. So let's look at 2x squared minus 80 is equal to 0. All right, just got the x squared, so I'm going to move the 80 over. I'm going to divide by 2. So x squared is equal to 40. I'm going to solve by taking the square root. So I'm just going to skip a step here and just say it's equal to plus or minus the square root of 40. So now what you're going to have to do here is look at this square root. Can I simplify this at all? Right? 40 is the same thing as 4 times 10. And the square root of 4 is 2. So this simplifies to plus or minus 2 square roots of 10. All right, let's try this one. This will be the last one here. Let's look at x plus 5 squared minus 7 is equal to 0. All right, so how are we going to tackle this one? Well, notice that you have something squared and then a constant here. So let me move the constant over, okay? So I have x plus 5 squared is equal to 7. Now going back, in all the problems I've done so far, it's just been x squared, x squared, x squared, x squared. But here I have an algebraic expression squared, and that is perfectly fine to solve by taking the square root. Look, the square root is going to cancel with this square, so I'm left with x plus 5 is equal to plus or minus the square root of 7. And then I'm just going to subtract 5 over. So this is minus 5 plus or minus the square root of 7. So just so we're clear here, you have two solutions. One is x is equal to minus 5 minus the square root of 7. And one is x is equal to minus 5 plus the square root of 7. Okay. So this square root property, again, just works really well when you just have a squared term, okay? And then you can move constants to the other side. Then boom, just use the square root to get rid of the square. And just remember, you get two solutions, one positive and one negative.